UN 영어뉴스 Euclid telescope first images revealed from dark universe mission. Spiral galaxy IC342, the hidden galaxy, is difficult to see because it's located on the far side of the Milky Way. Europe's Euclid telescope is ready to begin its quest to understand the greatest mysteries in the universe. Exquisite imagery from the Space Observatory shows its capabilities to be exceptional. Over the next 6 years, Euclid will survey a third of the heavens to get some clues about the nature of so-called dark matter and dark energy. These unknown influencers appear to control the shape and expansion of everything that's out there. Researchers concede, however, they know virtually nothing about them, even though they probably account for 95% of the contents of the cosmos. Neither dark matter nor dark energy are directly detectable. Our only hope of gaining some understanding is to trace their subtle signals in the things we can see. This will be Euclid's job, to observe the contours, distances, and motions of billions of galaxies, some of whose light has taken almost the entire age of the universe to reach us. Somewhere in the statistics of this 3D cosmic map, the largest ever made, scientists expect to find answers. Horsehead Nebula. The Horsehead is a great cloud of gas and dust where stars are being born. It's relatively close, just 1300 light years from Earth. Many telescopes have imaged this scene, but none have done so with the combined widths and sharpness that Euclid can achieve. Euclid's survey will be the most fundamental of inquiries, argued Prof. Carol Mundell, the Director of Science at the European Space Agency, ESA. We are human. We want to understand everything around us, whether that was as ancient people looking at the night sky and drawing constellations on our caves, or try to understand whether the sun would come back after the winter. We seek that knowledge and insight, she told BBC News. We don't currently understand 95% of the universe, a universe that is 13.8 billion years old. We are sentient beings who've been around for a tiny fraction of that time, but we could be the species to get to figure it all out. Dark matter and dark energy are among the biggest puzzles in modern astrophysics. The former could be some as yet undetected particle. Astronomers infer its presence from the gravitational pull it exerts on the matter we can see. Galaxies will fly apart if it wasn't there. The latter represents a very different problem. It could be some kind of energy in the vacuum of space. Whatever it is, it appears to be working against gravity to push galaxies apart at an ever-accelerating rate. Perseus cluster. The Perseus cluster is one of the most massive structures in the universe. This image contains 1,000 galaxies from this group, but beyond are tens of thousands more galaxies, some of whose light has taken 10 billion years to reach us. The 1.4 billion euro Euclid telescope went into space in July. Since then, engineers have been fine-tuning it. There were some early worries. Initially, Euclid's optics couldn't lock on to stars to take a steady image. This required new software for the telescope's fine guidance sensor. Engineers also found some stray light was polluting pictures when the observatory was pointed in a certain way. But with these issues all now resolved, Euclid is good to go, as evidenced by the release of 5 sample images on Tuesday. They are fantastic, said Prof. Isobel Hook, who worked on one the teams in the 1990s that first discovered the universe was expanding at a faster and faster pace. I finally saw the images at full resolution on Monday, and they really blew me away. We were expecting Euclid to perform very well, and it really has met all our expectations. It's a big relief and really wonderful to see, the Lancaster University astronomer enthused. NGC 6397, located a mere 7,800 light years from Earth. NGC 6397 is what's termed a globular cluster. It's an ancient grouping of stars, some of which are almost as old as the universe itself. They are cosmic fossils that tell us about the history of galaxies, such as our own Milky Way. No previous space telescope has been able to combine the breadth, depth, and sharpness of vision that Euclid can. The astonishing James Webb telescope, for example, has much higher resolution, but it can't cover the amount of sky that Euclid does in one shot. This giant camera, with hundreds of millions of pixels, is now ready to go and survey the distant universe and objects over a vast range of the sky, a vast volume of the sky in space and in time, said Prof. Mark McCogrier. It's only been looking at huge numbers of galaxies that we'll be able to tease out those subtle signals for dark energy and dark matter, which is what Euclid is all about, ESA's senior scientific advisor told BBC News. NGC 6822 evolved galaxies like our own Milky Way and IC 342 display beautiful spiral arms, but NGC 6822 is an example of an irregular galaxy. It doesn't have that defined shape. Many galaxies in the early universe look like NGC 682, although it's relatively close, just 1.6 million light years from Earth. Engineering challenge. No, this isn't some bizarre galaxy discovered by Euclid. The telescope had a problem locking on to a guide star during early testing until engineers could upload new software to its fine guidance sensor. The observatory was swiveling all over the sky. Artwork. Euclid has been given 6 years to assemble its 3D map of 1/3 of the sky. The telescope is special because it combines breadth, depth, and sharpness of vision. It needs these qualities to be able to probe a large volume of the sky within a practical time frame.